Hello, let me continue where I got what I call, rather I broke last time. This is all about 3D printing, and as I said, when you want to make technical objects, the issue is not simply about how to create an object out of your imagination. In this case, specifically everything is addressed to something has to be mass manufactured, something has to fit very well. So, last time when I left you with these two small circuits. So, I will see whether going here will help. Yeah, my friends have been good enough, and you see this, these two are the printed circuit boards required for a DC-DC converter, while on the outside they look a little same. Something else you notice is that they are not the same as we think they are. Why? I keep repeating, kindly what do you call, bear with me, saying why this repetition, but then the issue is about that on one side, while they look about the same, yeah, see here. Seen this, no? From the outside all the components look the same. We have a inductor, obviously there are two capacitors here, and these are slightly different capacitors. Only thing is the basic chip 2596 is probably the same inside, and then you see there is a number here, and then there is a 10-turn port, and most important, which in case you have missed anyway, I will not let you forget it so easily, is that this print is very, very different, and something related to this is the component build up. Have you seen here, this one looks like this top surface has been made flush, so that if you are to make a enclosure and it sits inside, it needs to be flush. This is what I was showing you earlier. The one I had showed you, I had made something for it where these capacitors are higher and then there is a small depression here. Now coming back to the, I will see whether the other one is yeah. You seen here, this is, that is that one here. If you see in the side view, this is depressed compared to the other one. So, and this picture what we have given here is about, just seems to be the other way. It is not about the type of capacitors we have here, but it is about the type of the mounting holes. And then how do we go about building a circuit for this? You have seen this here, these mounting holes are in one line, while in this circuit they are slightly different. You see here, this is not symmetrical, though it looks a little like an object that could be made symmetrical, definitely not symmetrical. You have a small what do you call, because of the various things of trying to make it small, they have pushed one of these holes here, and then another thing is this is exposed so that you can have a heat sink built into it. So, I think I have already shown you this, and I would like to show you this comparative thing one more time. You see here, while it looks symmetrical here, this is not at all symmetrical. See, this one is here. So, with the net result is the PCB has been made a little smaller. Now, I set about trying to see whether I can make an optimized enclosure for it. The next small exercise, and hopefully when we go back for the printing, we can see what it is. Do you see something very, what do you call, a little, I do not know either I should say it is amusing or say what has been done here is to maintain perfect dimensions and make a 1:1 representation, a picture was taken. Normally this is where we have a little problem. If you notice all the pictures that are taken earlier, they have a perspective issue. Unless something is flat, you cannot take a proper picture. In this case, it is not just about being flat, it is about being also aligned perfectly, because we want to make sure that the dimensions fit properly. Otherwise, we will end up with a very complicated, unnecessary. You have seen this? I have a beautiful picture. How this has been made was because since we have the printed circuit board and then it is not populated. On the other side, this is a, I am sorry, it is populated, but it is not from lead through whole system, the other operation is clear. It was put on a scanner and scanned. Advantage of doing this is now I have perfect location of these two mounting holes, and then something related, a little related to this is I have 4 places where the soldering can take place. And this is slightly different from what I showed you yesterday. What I showed you was this. You see here, I tried to make something which has a square opening here, and then we have some other thing, a round opening here, and then just to show you how the build up starts, how the material builds up and all that. This is sort of a recapitulation of what we started. So, this is where the starting, what I call this is support material, a hexagonal matrix like thing has been started, and on top of it the building has been done, and then if you see that continuous thread, that is all the where the material sits inside. So, if you see this is how the whole thing progresses, and if you get a chance and if the machine is free, I will see whether I will be able to build something for you. And only as a starting point, yesterday I showed you this saying we can make a box here, and I even made a step there to see if we can optimize something. Now today I will go away from here and show you some other way of how we can build another enclosure. See, the starting point for this was as before. If you see here, kindly have a look at my picture here. If you remember, that scanned picture has been put on a, we have taken a print out of it, then we have taken the actual piece which needs to fit here, and I have asked my colleagues from the workshop to measure and jot down all the correct dimensions, perfect dimensions. If you do a mistake, it will not fit. And then earlier we could afford to make things because there was always a issue of tolerances and fit and all that. In this case, no, we would like to be as close as possible. So, you have the, what do you call, this is the printed circuit and this is the scanned and printed object. Now, this object has been taken and placed here in my I have placed it after making a rectangle of the correct dimension. I have a rectangle of here, no, I have, if you see, I have a 20 mm by, see this is a 20 mm. 20 mm by 41 mm rectangle was what the measurement was made, and the whole thing has been kept at the back of my, the starting point of my, what you call, enclosure design. And you will notice that because of the, what you call, we want to make things a little small and all that, I have just given the absolute minimum gap that is required, and then which is still integral with the machine and its resolution. So, in this case it has been, one side it comes 0.4, other side 0.5 mm, and I have a very good starting point to start. Now, if I hide my this what you call tracing bitmap, this is a very good starting point for me. You have seen this, and you have seen here I have a circle which represents The circle represents the center point of the hole, and then the hole arrangement outside. So, I have a 20 mm by 41 mm rectangle, and all the various openings I want have been constructed here. Now, if I go actually trace it here, something else I have done here. If you see, after checking, I had to go back and see what is the opening that they have given in the circuit board. The hole that has been given in circuit board is a little more than a 2.5 mm, so it may be 2.6 or so. So, it has been found that if I keep a 2.5 mm screw, it goes through very well. Now, I look for a way of how to attach it down. As I have explained, as we explain slowly it will come together. I have put a 2.5 mm screw, and then going through the metric standards, I have checked and found out what is the pitch of it. The what I call ISO and our this thing says the pitch in this case is actually 0.35 millimeters. So, based on that, the whole thing was constructed, and I have come into an optimum shape of a hole. We see the outermost represents the 2.5 mm. So, if I go and try to give the dimensions here, oh, I am sorry, it says R. I think I need to pick up the diameter. It is a 2.5 mm hole. Inside the 2.5 mm hole, the 2.5 mm nominal diameter, in the case of our metric system, the outside diameter stated is 2.5. By various what I call actually it is by a little trial and error, something between this root, if we are to fully make a what you call a pilot hole and then try to drill a pilot hole, the pilot hole would have come at that level. Instead, because I do not have a provision for that to sit here, what has been decided is I will attempt a square hole which is a little smaller than that, so that I still get something which is not bad. So, the pilot hole comes here. I have tried this square hole earlier and have come to an approximate size which is 1.77 mm. This has been the basis and starting point for my design here. You see here. Now, this is where I need to take a very interesting what you call build up about it, saying if you look at this printed circuit board which I have shown you earlier, one of the things you will notice is that this is the one I am trying to build. Seen here, see the small detail here. So, I need to support a hole here and I do not have much place here, very little place is available for me. Same thing on this side also. If I come close, you notice that this surface mount device capacitor is the limitation here. The amount of space I have is a surface mount limitation. Similarly, here I have a small SMD, another tiny, I do not know, probably it is a resistor, and within this is where I have to support this hole. So, I come to the what I call dilemma, saying what do I do now. So, I have decided provisionally to make a square starting from here, going all the way from here to the other place. And then what do I do about this what I call outside soldering? I have decided to relieve that thing to a small step. So, I end up with a square what do you call I am sorry, rectangular piece which can go and attach itself to, seen this here, no. Now, I will unhide these items. Now, you see here I have a box and this whole thing gets attached here, and the square, this corners represent the holes in and out, openings like that. I have this issue of having to worry about it only at two places here and there, and at these 2 points it is not a big deal at all, because there is nothing which is occupied in this. So, now if I build based on that, I will have a beautiful enclosure which is built here. In this looks like it is very easy. Depending on your patience and so on, I would like to still show, perhaps in case you are interested, only in case you are interested, on how this whole thing has been built up. In this case it is very easy. See this, no, I have a box. This is the box which sits here, nicely it sits here, and then it has been converted into a what do you call a piece like this, which can be happily extruded. This being a hey, it is a cinch. Without too much of an effort, I have a beautiful box getting ready. In this I have it, no problem at all. And then if you remember, in this corner I had created something else here in this corner. See here, this one, same way I just need to extrude it out. Interesting, very easy. Once I get all the dimensions and already, making anything like this is extremely easy. Now, we come to the other 2 points, saying I have 2 small square holes which need to be made. Oh, I do not know what to do about it, somewhere it has got locked. You see here, at the base of it I have this small square hole. So, I have similarly I have this another square hole. Now, I try my best to take it up and see. Oh, it is really a cinch. I have got this. Life is, life can't be what you call easier than this. Now, and if you remember that corners, I still have the issue with the corners, saying somehow I need to make a place in the corner. I do not know whether I have the information here, or maybe information is lost, but still nothing is lost as such. For me to give a small relief in the corner, it is very easy for me to make a small what you call solid, a box. See, I have got this nice box which I can use for removing material. I will copy it again here and see whether if it is a symmetrical object it will be useful for me. It does, it is useful, not very symmetrical, maybe I should rotate it. Hey, it is symmetrical, who said it is not symmetrical? Four and a half millimeters, 4.4 millimeters, not bad. So, I will just leave it like that, I will take it here. Good. So, right now looking here, see this, I have the small this thing on top. I will now try to use and try to make a depression on top and achieved. So, I have a beautiful what you call device which is ready, and I need to do something to make sure that it works properly. Only thing here is at this stage I tried to stop it here because this can be used for both types of printed circuit boards when made in what you call, I will say call it parts, so that I can use it as a universal thing henceforth. If I have this corner support, I can use it for any printed circuit board. Any printed circuit board I have which involves a similar type of a thing at the corner, I can just put it and make a relief and so on. One thing you will notice is no detail has been shown here as to how the wires will be taken off like that. One of the best way is probably to take a U thing here and take the wire here, or depending on what it is. No, normally that is what we will do here. We will take a small cylindrical shape here somewhere in one of these places, and then I will see if I can make a solid which is typically a cylinder. In this case, in this view, I would like to make a cylinder which is typically if I see here, it shows this is a 2 mm hole, this is a slightly bigger hole. Again going by the same earlier sorry, yeah. Do we need to make, if you make a circular hole where it is convenient and the wires can all sit there and all that, we still have the old problem of when things build up, how the slicing is done and how the things are built up. So, it is not a very good idea to start with circular things, because we end up with a support, and then the moment the support issue comes, we will come with more and more material to be stacked and so on. So, in fact, I can probably I can do much better without this and instead make a rectangular opening here, which is very easy for me. So, I go back here, look at this, try to make a surface which is a plane. The rectangle can just be this is the plane, it is sitting at the bottom here. So, bring the plane here, try to extrude it down. See here, now I have a chance of making a simple notch, which is a square or rectangular notch. Now, I will copy this notch in all the 4 places. So, going back to the perspective view, I have managed to achieve 4 openings. So, it is easy for me, I go back to solid, I make a difference of my unit is almost ready. See this? Easy for me, life is probably. Now, if I go here and try to see what a cute object it is. Now, when I want to build it, depending on the way I place the components and so on, it builds easily without the slightest what I call issue about it. It will start at the bottom and then slice by slice the whole thing builds up. This being square, overall build is going to be very easy. So, what I will do is I will now save, open one more which I have created earlier, and then I will show you how the slices are going to be built here. This one is a little similar to what I have already shown you here earlier, except that to demonstrate how the slices are built up, I have what you call cut the thing into the various types of slices, and one after the other you will be able to see Oh, there is a hang up. First slice, the layup is going to start like this. So, if you see the layup, whole thing will be filled one after the other, the items will be filled. After that, next one if you see already next bit of a thing is being built here. Now, you will notice that nowhere there is any undercut that has been given here. You understand, no? All of these, from these one by one they will all build the easiest without the slightest problem. You can see that the whole thing is being built like this. Now, if I give a oh sorry, I do not know why it is behaving like this. Yeah, you see this. One or two things you will notice is there are no fillets or chamfers that is given anywhere. The chamfering and filleting that may happen here is because of the way the layup of the material is done, which is very little, maybe it is less than 0.1 to 0.05 mm. So, one after the other, these are all almost common. So, I will drag the whole thing here. Now, we come to the last three where a small difference there. Can you see here? This is a partly closed thing here. You will notice that when it lays up, it starts laying up, but then about 1/3 or 1/4 of it already a depression has come here. So, if you see here, this slice alone is probably likely to look like this, and when these slices build up one over the other, see the first thing has started. This is almost complete the way we want now. All the detailing that is required has already been fulfilled here, and see this, we have a beautiful thing, except that what is it that I did not have? I did not give that rectangular what you call opening thing. I have a reason for it. One of the reasons being that I may not want to have the holes directly here and the circuit coming from here. I would not mind having the circuit being, see this is going to be like this, and then I have a cover on this. If you remember, no, I said I am going to have a heat sink on top of it. So, after putting all these things here, I will now, after my trial is over, I will probably, the second object which I am going to print will probably have to have that saying, would I take my what do you call my wires from here by drilling 4 holes in the aluminum, or will I make anything? That I need to do after the assembly is, first assembly is done. Second print is going to have it, and in the unlikely case, once I put a what I call heat sink on top of it, I can drill holes on the heat sink and have these wires stick out. Alternatively, it is very easy for me to file out a few what I call 4 openings here and make it. So, intentionally I have what you call left it here. So, next one is going to be this is the fairly completed you call object. Can you see here? To make this thing interesting, what has been done is I have given a small radius here. It is in our human this thing, we can only perceive objects when two surfaces meet and the highlights are caught here. So, beautiful highlight is being caught here, because of that now this object looks more real than a simple flat rendering. So, this is a flat rendering, okay, with you see here small corners have been given here. This looks a little more natural. Once the printed circuit board is kept, and then after that I clamp this 4, now I decide what to do with it, and then on the other side I have this hole, and then hole has been made. If you notice here, compared to all that fancy depression and all that, this object is going to be much easier to lay up. So, extremely what do you call, it's tiresome for you, and maybe a little bit of tiresome for me also, but you see in the end we have these, if you try it you can't be wrong. See here, nice, all I can say, only thing I can say is nice. And even if you were to make an object, very rarely this object will be smooth and the way it is here, because remember what you are laying up is still a tubular structure. So, in reality if I now use a very thin what do you call filleting, I will probably able to make out a little about is intentional. Intentionally I am making sure that I will not pick my computer is slow. Oh, finally, any object that is going to be created in 3D printing will have this little bit of granular structure. This of course intentionally made what do you call, with respect to each slice the radius is very small. So, you will not have them like sliced, but you will have large number of what do you call grooves on top of it. See this, no, this is going to be my final object. Now, one more thing I thought I should see this here. Now, is it possible for me to make it look like a real object? Yes, very much, it is very much possible for me to make it look like a real object. One of them is, can I put a what do you call a cover on this, which typically represents the same circuit which I have seen here. If you have seen here, I have a picture of a circuit here. Is there a way of my placing it on top of that? Yes. If I see I need to open this probably in Paint.